Time Traveler's Guide: Why Time Whispers in Space. Ever wondered if you could cheat Father Time? What if I told you that space holds the key to manipulating time itself? We're going on a journey to explore a mind-bending phenomenon, time dilation. It's a real effect where time passes differently depending on where you are in the universe. The secret lies in Einstein's theory of relativity. It's the foundation for understanding how gravity and speed warp the fabric of time. Our goal is simple: to explain why time passes slower in space. Prepare to have your perception of reality challenged. Imagine you're an astronaut, gazing back at Earth from your spacecraft. You notice something strange. Time seems to be flowing differently. Your loved ones on Earth are aging faster than you are. This isn't science fiction, it's time dilation. It's the stretching or compression of time relative to different observers. Think of two clocks, one on Earth and one in your spaceship. The clock in space ticks slightly slower. The first key ingredient in our time-bending recipe is gravity. It's not just what keeps us grounded, it also affects the flow of time. Picture a black hole, an object with such immense gravity that nothing, not even light, can escape. It warps space-time around it. Imagine a ball rolling down a hill. The steeper the hill, the faster it rolls. Similarly, stronger gravity means slower time. The closer you are to a massive object, the stronger the gravitational pull, and the slower time passes for you. Earth's gravity slows time down slightly compared to deep space. But near a black hole, the effect is extreme. Imagine an astronaut approaching a black hole. To an outside observer, their time would appear to slow to a crawl. Now, let's add another ingredient: speed. The faster you move through space, the more time bends. Envision a spaceship hurtling through the cosmos at incredible speeds. What happens to time inside? Consider two identical clocks. One stays on Earth, while the other travels on the spaceship. The faster you move, the slower time passes for you relative to someone who is stationary. It's counterintuitive, but true. The speed of light is the ultimate speed limit in the universe. It's constant for everyone, regardless of their motion. Imagine a beam of light approaching a moving observer. To maintain its constant speed, time itself must slow down for the observer. So, what does this mean for our astronaut? They're experiencing both weaker gravity and high speed. These two effects work in opposite directions. Weaker gravity speeds up time, while high speed slows it down. The overall effect is that time passes slightly slower for the astronaut compared to someone on Earth. For short trips, the difference is minuscule. But over years of space travel, the time difference becomes noticeable. Our astronaut might return to Earth having aged slightly less than their Earthbound counterpart. They've effectively traveled a tiny bit into the future. Time dilation isn't just a theoretical concept. It's a real phenomenon that has been experimentally verified. Scientists have conducted experiments using atomic clocks, the most precise timekeeping devices ever created. They placed one atomic clock on Earth and another on a high-speed airplane. The clock on the airplane ticked slower, confirming time dilation. This effect is even taken into account in GPS satellites. Their clocks run slightly faster in space, and the system corrects for this to ensure accurate positioning. Next time you gaze at the stars, remember that time is flexible. It's not a constant, but a river that flows at different rates depending on gravity and speed. Perhaps one day, we'll be able to harness time dilation for interstellar travel. Imagine journeying to distant galaxies, experiencing time differently than those back on Earth. The possibility of traveling to the future, even in small increments, is within the realm of scientific possibility. The universe is full of wonders, and the secrets of time are just waiting to be unlocked.